All right, chapter 6, lesson 2, and this is actually the last lesson that we do in chapter 6. You'll do some more of this next year, moving on to trig or pre-cal. So looking at 6.2, we are talking about inverse functions and relations. The very first example that we're going to do is going to give you a set of ordered pairs and ask you to find the inverse of them. That's just a matter of simply whatever your x value is and your y value is, you are literally swapping them. So if your x value is originally positive, it's going to stay positive when it moves to the y value. If it's originally negative, so like if this had been negative 1, 5, when I'm flipping this, it would become 5, negative 1. So whatever your sign is going to stay with it. You're not changing signs. You're literally just taking x and making it y, and y and then making it x. So you're just swapping places. Example 2 that we're going to get into also deals with graphing, but instead of giving you ordered pairs, it's now going to give you a function in slope-intercept form. There's a process to that one, which we'll talk about once we get there. And then example 3 is something different that we'll go over a different day, where it's asking, are these two functions inverse of each other? There's no graphing involved in that one, so we're going to just look at example 1 and 2 today. So for example 1, it tells you the ordered pairs of relations 1, 3, 6, 3, 6, 0, and 1, 0 are the coordinates of the vertices of a rectangle. So I'm going to stop there. The first thing that I'm going to do is graph those points, just so I can see the original shape on my graph. So whenever I graph this, I would have a point at 1, 3, 6, 3, 6, 0, and then 1, 0. So this is my original shape and my original points. The next part of the question asks you to find the inverse of this relation. So what I'm writing are the original points that are given to me. And then it is asking me to find the inverse of these points. So the inverse is going to be where you're just swapping x and y. So 1, 3 is now going to become 3, 1. 6, 3 will be 3, 6. 6, 0 will be 0, 6. And then 1, 0 will be 0, 1. So these are my new points that I'm going to now graph on the same coordinate plane so we can kind of actually see what happened, because the next part of it's going to ask you to describe the graph of the inverse of like how they're related to each other. So graphing 3, 1, I would have a point here, 3, 6, 0, 6, and then 0, 1. So my new inverse looks like this. If it helps you to use two different colors to see like the original and the new one, you're more than welcome to use that on homework, or if you need to do it on a quiz or test, totally fine as well. From here, what the next part is asking you to do is to describe the graph of the inverse. So kind of stating like how it actually changed, or how it reflected kind of. So if you're looking at your original one is on your x-axis, and then it kind of flipped over to now be on your y-axis. One way you can think of that is that it's kind of a horizontal reflection, to where, or it's, this line is really showing you where your reflection is. So it reflected from the horizontal to the vertical. The other way that's kind of easier to write that is just that x and y are equal to each other, meaning it started on x and then it flipped to y, which should make sense to you because my y values became my x values, and my x values became my y values. So you can kind of describe by drawing a line on your graph that shows where the reflection happened, which would be this line right here. Or you can actually write out, and it doesn't have to be a complete sentence, but you can also just write out like it started on the x-axis and then reflected to the y-axis. The easier way to say that is that x and y are equal to each other. Whatever makes the most sense in your brain as far as like how to actually describe it. If you need to write a sentence, write a sentence. If you can show on the graph with a line to show where it actually reflected, that's fine as well. So that is it for example 1. Relatively simple. You're just swapping x and y points and then graphing them and explaining how the actual shape changed. Generally these types of questions are generally going to be a shape. It's generally going to be a rectangle, a triangle, something along those lines, versus example 2 that we're getting ready to get into is going to be a line. You might see a line on this question, but it's going to be the same type of scenario. So for example 2, it says to find the inverse of f of x equals negative 1/2 x plus 1, then graph the function and its inverse. So the first thing that I would do in this question, f of x is really your y value. So the first thing that I'm going to do is to graph my original function. So just my normal function that I'm given. It's in slope-intercept form, so it's relatively simple to graph. So remember, when you're graphing slope-intercept form, the first thing that you're graphing is your y-intercept, which is 1. Then I have a slope of negative 1/2, which means I'm moving from that point down 1 and then to the right 2. And then I would continue that pattern of moving down 1 to the right 2. If it's a negative slope, I know that my line is going to be decreasing. So this is my normal function that was given to me. In order to find your new function, you have a process of how to change your actual equation. So what your steps look like, your first step is going to be changing, I don't want to say changing, I'll say swapping. That makes more sense. So your first step is going to be to swap the x and y in your problem. So what I mean by that is where your y is going to become x, and where your x is going to become y. So I'm going to change this to x is equal to 1/2 y plus 1. Then from here, your next step is to solve for y. So I need y by itself. So the reason I swapped them, thinking back to example 1, my x and my y values swapped, which is how I'm finding the inverse. So in this question, I'm literally swapping x and y again to get that inverse, but now I have to essentially solve for y to put it back into slope-intercept to be able to graph it, is why we're solving for y again. So I'm going to solve for y. So in order to do that, I'm going to subtract the 1 from both sides. So now I have x minus 1 equals negative 1/2 y. Then to get y by itself, if I have multiplication, to move it to the other side, I'm going to divide. However, because it's a fraction, dividing by a fraction is going to turn into multiplying by the reciprocal. So instead of dividing by negative 1/2, I'm going to multiply by negative 2, or negative 2 over 1, however you want to think about it. Whenever I multiply that to the other side of my equal sign, the negative 2 is being multiplied to the x and to your negative 1. So it's not just going to one of them, but it's going to both and being distributed to both. So when I do that, I now have negative 2x plus 2 is equal to y. So these are going to cancel each other out. The last step kind of your process is to change your y to f negative 1, or f to the power of negative 1x. That represents, so your original function is given to you of f of x. F of negative 1x is just the shorthand version to be able to say this is an inverse function. So whenever I did the original, this is now the inverse of that. So I would just simply rewrite it so it's f negative 1x is equal to negative 2x plus 2. So my y is replaced with that. So this is part of your answer because you do have to find the inverse. That's what the very first thing says, is to find the inverse. So this is your answer to that first part. Then it asks you to graph the original function, which we already did, and now the inverse. So graphing your inverse, my y-intercept is at 2 now. Then my slope is at negative 2. So a slope of negative 2 would tell me to go down 2 to the right 1, down 2 to the right 1, so on and so forth. So your new graph will look like this. And that is, again, also part of your answer. So your answer is actually working out all of these steps to get your new function, and then graphing the original function and your inverse function. Again, if you want to use 2 different colors and it helps you understand which one is which, feel free. That is up to you.